All right, today we will determine if a relation is a function. We're going to talk about different function representations. So we're going to be able to model various relationships in different ways. And then we're going to do a little bit of practice and hopefully crush it. First up, relations, functions, and multiple representations. The essential question here is, what is a relation and a function, and how are they represented? So we've got a few keywords: relation, function. Okay, so the first one we got is relation, and that is a pairing of an input or x value and output y value. And then we usually get a set of ordered pairs. We could also represent that set of ordered pairs as a list, a table, a mapping, or a graph. We're talking about discrete relations today. So that means that we have points, and each point has an x and a y. And when we have a point with an x and a y, we write the x before the y, and we always put them in parentheses with a comma in between them. For example, we could have the point where we have 3 is related to 7, and we can put parentheses around those. And now everyone that knows algebra will be able to look at those two numbers in the parentheses with a comma and say, that's an x and that's a y. Although sometimes we want more than just one point, and that's where we have a set, a collection or group of objects, and we list those in braces. I sometimes call those curly braces or curly brackets, and they're kind of hard to draw, so I'm going to draw them kind of look like this. Now, they're not parentheses, but we use these if we wanted to leave a collection or a group of objects. So let's say we wanted a list of points. 3, 7 could be one, but maybe we have another one. Maybe we have -4, 2, and a third point at 0, 2. And those would be a set because it makes a collection. I'm telling you not just that those are 3 points with x's and y's, but also that they are a set because I group them together with curly braces. Now, that is just one way to represent a relationship. We could write a list of ordered pairs, just like we just did. Or we could do a table, and that's where we put an x and a y, and that's kind of like a list of ordered pairs, except it's organized in a different type of list because the x's and the y's are next to each other, and then we stack them on top of each other instead of right next to each other. So not a big difference. Then we could have a graph. The key with graphing is that we have to graph each point carefully, making sure we're graphing the x left and right and the y value up and down. And so each of these points, for example, what point is that right there? This green point, this little point right here that we're pointing to, that is 1, 1, 2, 3. It's 3 boxes over from the middle, 3 boxes to the right, and it's 1 box up. So that is 3, 1. I want to look at this point down here. That point is not 3, 1. It's going left 2. So that's an x value of -2, and it's going down 2. So that's also -2. Okay, so hopefully you already have seen coordinate plane and been able to graph points, but I do want to highlight the fact that these 4 points are the 4 points that we listed here, and the same 4 points that we have in this table, and then they're also the same 4 points we listed in this mapping. What might throw people off is the mapping doesn't look like 4 points. If you take a look at the mapping, what we see is we see 3 input x's and 3 output y's. So it looks almost like there's only 3 points. But I want you to notice that there's actually all 4 points there. So the first one we're going to look at, I'm going to look at the table here. In this table, -2, 2 means I start at -2 and I draw a line to positive 2. So if I do that, negative 2, 2 is that point right there. So in a mapping, we don't repeat the numbers, which means in my next point, where I have negative 2, negative 2, I still start at negative 2, and I didn't draw another negative 2 in that circle, in that map. So mapping is weird because it's just a weird representation, but once you know the rules, they're pretty easy to draw. So if I go from negative 2, my y this time is actually negative 2. So I have a negative 2 in my output as well. Then you can see that we have the 0 and the 3 both go to 1 in our output. Okay, so a mapping, a graph, and a table. These are 3 ways, the fourth being the list at the top, that we can represent a relationship of x's and y's, of input and output. Let's look at an example. Oh, we should probably talk about functions while we're at it. So the first example we looked at, these 4 points are a relationship, but they are not a function. A function is a relation where each input has only one output. So each x has only one y. Which means if you have a list of ordered pairs, x's cannot repeat. Or if they do repeat, the relationship is not a function. And so if we look at our last example, when we had an x that was a negative 2, sometimes it gave me a negative 2, and sometimes it gave me a positive 2. And so the relation that we saw in our last example, the x's repeated. And when they repeated, they give me 2 different answers. But our rule says that each input has only one output. So every time I get a negative 2 for an x, I should get the same y. But that's not what happened. In fact, our mapping shows us this. When we look at our mapping for that, 1, negative 2, negative 2 went to two different places, and that's not okay. It is a little bit easier if it's graphed, however. We don't even need to look at the numbers. If it's graphed, we can very quickly tell using the vertical line test. The vertical line test requires that you know vertical lines go up and down. And then we just simply draw a vertical line on the graph. And if anywhere on that graph we can draw a vertical line that touches the graph more than once, it is not a function. Okay? If it touches the graph at one point at a time, it is a function. So if we look at this example here, nowhere can I draw a vertical line going straight up and down and touch the graph more than once. I'm only ever hitting the graph once. And so I hit a graph right there. When I do it there, I do there, I do there, I do there, but only one at a time. The difference is over here, when I draw a vertical line, I hit the graph, that curve, in 2 places, which means this is not a function because it fails the vertical line test. This one is a function because it passes the vertical line test. Okay? Let's look at some examples. I'm going to go ahead and just run through a few of these. The first one, we have a table. We're given a table, and what we need to do is we're going to represent it as a list of ordered pairs, a graph, and a mapping. And then we're going to say whether it is or is not a function. So first thing I'm going to do is I'm going to take my x's and y's in my table, and I'm going to make a list of ordered pairs. I'm going to think about them with parentheses around each one and with commas in between each one. Now, I can't just say that's good because I have to write this in curly braces. So let's do it. curly braces, -4, comma 0, always the x's first, comma because I have a second one, -2, comma 1, close, comma. I'm going to move on to the second line here. 0, comma 3, and comma 3, comma -1. And then I closed it with a curly brace. The next thing I'm going to do is I'm going to graph those points. I'm going to start with my x. So my left and right is my x-axis. My y is my vertical axis. So if I go ahead and plot those, I start at -4, and then I go up to 0, so I don't go up at all. That's my first point. Then I do -2, and I go up 1. And then I try 0, and then I go up 3. And then I do 3, and this time I'm going down to -1. So I have my 4 points on my graph. The next thing I'm going to do is I'm going to do my mapping. So if you notice in my x's up here, none of them repeat. So I am going to put them in order, but they're already in order. So I'm going to go ahead and just copy right down. -4, -2, 0, and 3. For my output, none of them repeat, but they are in the wrong order. So I'm going to go ahead and put -1. I'm going to put 0, 1, and 3. Now I have to connect my input to the right output. So -4 goes to 0, -2 goes to 1, 0 goes to 3, and 3 goes up to -1. So I have 4 lines, and I'm done. Although I do need to pick whether it's a function or not. Now I'm going to use vertical line test. If I use vertical line test, is there ever a point that I can hit multiple points at the same time? So I'm going to try all 4 points. If I draw a vertical line, do I ever hit 2 points at once? And in this case, I don't. So I'm going to say function, yes. And the reason I'm going to say is vertical line test. I use vertical line test, and I just checked it out. Let's try another example. This time it gives me the mapping, and I have to do the table, the graph, and determine whether it's a function. If you want to, you can go ahead and try it out. I'm going to jump right in. Ordered pairs first. I'm going to do my list. So I need brackets. I'm going to do the braces, the curly brace. Now I've got a mess here. So I'm going to not think about each one of these numbers like an ordered pair. I'm going to think about each one of the lines like an ordered pair. So my first line I see is from -3 to -2. -3, comma, -2. Now I'm put a comma. Next line I see is from -3 to +3. Put a comma, and the next one I see is from 1 to 2. I'm always moving left to right to go from my input to output. And I'm just kind of working my way down this page. So now I'm going to go from 4 to -1. And I use a curly brace to close it out. Oh no, now my curly braces are different colors. Let me switch that. Now I'm going to make a table. I'm just going to write them in the order they're in. I'm going to make sure my x's are in the right order. So it looks like my x's, because they were in the right order when I was looking at my mapping, they should be in the right order when I fill out my table. So I have -3, and then -2. I've got another -3 and a 3. When we're doing a table, we are allowed to repeat, because how else could we represent the ordered pairs? So the next one becomes 1 and a 2. And lastly, 4, -1. Now I need to graph each of these. I'm going to use my graph right here to go over 3, left 3, and then down 2. I'm going to go over 3 and up 3. I'm going to go right 1 and up 2. I'm going to right 4 and down 2. All right. And then the last thing I have to decide is this a function? Now, I'm going to use the vertical line test because I have a graph. So I'm going to draw a vertical line at all the places I have points. And do I ever hit more than one point at a time? And the answer is yes. I have 2 points that are on the same vertical line, which means this is not a function. No, not a function. And why not? Because of the vertical line test. Now, some people might have noticed that we have 2 x's. So another way we could say this is we could look at the 2 x's and say the x's repeat, but then the y's are different. So the x's aren't supposed to repeat when we have a function. And so that's another reason we could give for why it is not a function. But I just went ahead and looked at the graph and said it failed the vertical line test. I have one more example for you. This one is a graph, and we need to write the list of ordered pairs. We need to write a table and the mapping, and then decide whether or not it's a function. Go ahead and you try this on your own. Go ahead and pause it. See if you can do this one without me. And then I'm going to jump right in. All right, I'm going to start with the ordered pairs. I'm going to do my curly brace. It's kind of like a weird 3. And then I'm going to go ahead and put my parentheses. So I have 1, 2, 3, 4. Oh, I made it. I was checking because I think I made it too small. I got to write smaller. There we go. And then I put a curly brace at the end. I make sure I have commas in between all of my points. And I actually need a comma inside each of my parentheses right in the middle because I have an X and a Y. And I'm just going to move from the left to right. So the first point I have is at negative 1, 2, 3, 4, 5. So negative 5, and it's up 1. The one I have in the middle is at 0, but it's down 2. The next one is over 2, but then it's up 0. And the last one's a little bit over 3, and it's down 2. All right, now I'm going to make a table. I'm going to use my ordered pairs for that table, so I'm going to just keep them in the order I did. Since I work left to right, they're already in the right order for the x's. So I go negative 5, 0, 2, 3, 1, negative 2, 0, negative 2. And I'm going to finish up with my mapping. And since they're already in order, it shouldn't be too bad. And I don't even have any repeats on my x, but I do have a repeat on my y. So I'm going to do my y's in order, and I'm going to try not to repeat. So the first one, the lowest one, would be negative 2. We start from the bottom, negative 2. And then it'd be 0 and then 1. So I'm going to start drawing my lines, and I see that 5 goes to 1, 0 goes to negative 2, 2 goes to 0, and 3 goes to negative 2. All right, so we've drawn our mapping, our table, and our ordered pairs. The question is whether it's a function, and it kind of threw me off. It's weird that we had a missing number. On the last one, all the numbers, matched in the mapping. And in this one, we have only 3 in the y. So that meant that 2 of the x's shared the same y. But let's take a look at the graph. And we're going to check the vertical line test. So I'm going to draw a vertical line everywhere I have a point. And do I ever hit more than one point at a time? And the answer is no. So I do pass my vertical line test. So yes. And the reason it is a function, I can say my vertical line test worked. Now, if you thought that I was going to say no because we have 2 x's that have the same y, that's allowed. What I can't have is when the x's repeat, and the x's don't repeat. The y's are allowed to repeat, and that's fine. All right, I want to take a look at your homework, a little practice here. because I wanted to show you a few little things that might trip you out. The first one is when it talks about the words domain and range. Okay, those are words you should know already, but I'm going to toss them at you. Domain just means all the x's or the input, and the range is all the y. So in order to fill out this homework, we need to list the domain and range, and we're going to use braces for the set of the domain and range. For example, in the first one, the domain of this function, oh, that's a bad one. I'm going to try to make a nice curly bracket here, curly brace. And the domain is not going to be like we did on the notes where we have ordered pairs, because we don't have the pair for the domain. We're just looking at the x's. So we're going to list all the x's. We have 1, -2, -1, and 1 again. But just like when we're doing a mapping, we do not include repeats when we write the domain. So we can leave it just like that. It's okay if it's not in order. Some people out of habit always put it in order just like they would for mapping, but that's okay. The range in this one, it's going to be all the y coordinates. So it's going to be -2, 0, 2, and 3. When we talk about whether it's a function, we can look at whether it repeats. So do we have x's that repeat? And the answer is, yeah, we do. We actually have 1 twice. Are the x's allowed to repeat? And the answer is no. So this is not a function, okay? So as you go through, put the x's as a list for the domain, and the range, you're going to put the list for the y's, okay? So you can see that same kind of thing on number 2, number 3 and 4. And once you get down to number 5 and 6, what you want to try and do is when it says write the relation, it says write the relation. That means write the list of ordered pairs. So, for example, if we were going to go ahead and do number 6, we go ahead and write the list of ordered pairs. There's 4 of them. And then we have a curly bracket. So then we would also have the domain and range. And lastly, we could use the vertical line test when we're looking at the graph. All right. So the last section, number 9, 10, 11, 12, it actually says express them as a mapping and then state the domain and range. And so when we do that, we're going to have to go ahead and write each of those as a mapping, just like this. And we go ahead and list the domain and range in order. So in number 9, we have -2, 0, and 5. And the range in number 9 is -2, -1, 3, and 4. And then we can go ahead and map them by going one by one. And then we watch out for cases where x's repeat but go to different y's. And so this one would be a no. I still want you to list the domain and range in the curly braces, just like we did for number 1 up the top. Okay? Good luck.